All right, so let's go into our last section of chapter 6 here, talking about inequalities in two triangles. This section is going to focus on one major idea, which is called the Hinge Theorem. And so we're going to jump right in here and talk about what the Hinge Theorem says. And so it starts off with just kind of visual. What's going to be the main idea that we're looking at here? And so we're saying, like, if we imagine a gate between two fence posts, so we've got fence post A and fence post B here, and we want to have a gate in between. So here's my gate. As I swing that gate open, some things to consider in that situation when I'm looking at between those posts and looking at that gate as it opens up. One of the things that happens is as I open that gate, we can think of this as like creating a triangle between points A, B, and C. So A and B are the goal or the fence posts. Point C is the end of the gate, kind of where the handle is. Now, as I continue to open that gate further and further, I create a different triangle each time as I continue to swing that farther and farther open. Now, one thing to note is as we do that, okay, as we swing that gate open, notice the length of the gate stays the same all the way throughout. So A to C doesn't change. I'm not changing the length of the gate or the width of the gate as I open it up. It's going to be the same length every time. Also, the fence posts aren't moving any closer or farther apart, so the distance from A to B is going to stay the same all the way throughout. And so what's happening here is two sides of my triangle are staying fixed. They're always going to be the exact same length as I go and open that gate further and further. But what is happening is as I do that, side BC, so the distance from fence post B to the end of the gate C gets further and further or longer and longer. And so also then what's happening is not only is it getting longer, so BC in the first picture right here is the shortest distance right in the three pictures. Also, we've opened it the least amount, so angle A is the smallest angle in the three pictures. As we go to picture number 2 over here, we've opened the gate a little bit further, which means this angle A is now bigger, as well as this side BC is bigger. And then as we continue to the third picture, we've opened it up even further, so we have an even bigger angle A, and therefore an even longer BC. So what's happening is two sides of the triangle are fixed. They're not changing throughout the entire process, but as the angle A gets bigger, so does the opposite side BC. So the BC in this picture is bigger than the BC in this picture because the angles are bigger. And that's the whole idea of this Hinge theorem. So what the Hinge theorem is saying is in a triangle, and again, this has a lot of words, so just kind of pay attention to what I'm telling you here. If I get two triangles where two of the sides are fixed, so I see these little markings that tell me these two sides are fixed, VX and VW, RS and RT, those are fixed and they're marked. Now what they're saying is if I open V to 88 degrees and I open R to 35 degrees, then between the opposite sides, so between XW here and ST here, which side is going to be bigger or smaller? And so the big thing is, whatever is across from the biggest angle is going to be the biggest side. And whatever across from the smallest angle is going to be the smallest side. It's a lot like what we talked about in the last section within the one triangle. Biggest angle, biggest side. Smallest angle, smallest side. So down here in the statement, we're saying that side WX is bigger than side ST. So WX has a larger value than ST because it's across from the bigger angle. And again, we could flip that statement. ST is less than WX because ST is across from the smaller of the two angles. And that's the whole premise of the Hinge theorem. Even if we look at the converse, it says exactly the same thing. If I'm looking at this triangle, two sides are fixed. So AC and BC are fixed, DF and FE are fixed. We see the little markings. Now, if I look at the two sides that they give me, AB has a length of 12, DE has a length of 9. What they're wanting to know is which angle. So across from 12 is C, and across from 9 is F. Well, because C is across from the bigger side, it is bigger than angle F. Or again, we could flip that. Angle F would be less than angle C because it's across from the smaller side. So basically what you have to understand here with this hinge theorem is the big is across from the big, the small is across from the small. If they're both equal, like we had in the last section, that can also occur. That just means the angles are equal, or the sides are equal as well. So if they're the same, then everything's the same throughout. So if I use this hinge theorem, so if I look at an example here, so it gives that line ST is congruent to PR. So they're telling us this is congruent to this. That's a fixed side. And then we go to the picture and we notice that there's a shared side in the middle. So that shared side is going to be fixed as well. So we mark that. So now I've got two sides fixed in either triangle. What they want to know is how does angle PST, so that's this angle right here, compared to SPR, which is this angle right here. And so I'm going to use a different color so we really can differentiate here. Okay, so we've got PST in red, SPR in blue. Now, if I look here, SPR is across from a 23-inch side, and PST is across from a 24-inch side. So if the other two sides are fixed, but angle S is across from a bigger side than angle P, then I know that angle S is bigger than angle P. So the way I would write this out, the measure of angle PST must be bigger than the measure of angle SPR. I know those two angles have to be related that way because SPR is across from the smaller side in the figure. So big side to big angle, small side to small angle. Same thing here, kind of going the other way. If we have PR and PS are congruent, so we're marking those two sides there, and then again we have this shared side, we have our two fixed sides. Now it says angle QPR is bigger than angle QPS. So QPR over here is bigger than angle QPS over here. So the red is bigger than the blue. Now if you need to, just for visual purposes, make up some numbers. Like say QPR is 40, and that means QPS has to be smaller, so call that 30. And now if I follow it across to the opposite sides, I know that side SQ is going to be smaller than side QR. Okay, so with that, you should be able to go through the worksheet, make sure to ask questions, check the answer key as it comes available, and then make sure that's ready to go when we turn those in a couple of days here.